Considering the distance of only 7 million kilometers, one might expect that it would be burning hot on the planet's surface. This is valid, yet only half of the time. Essentially, Proxima Centauri is a red dwarf whose mass is just around 12% of the Sun's mass. However, the data gathered so far indicates that Proxima B has a bound rotation, which means it always presents the same side to its parent star. Thus, the exoplanet is divided into a freezing cold night side and a significantly hotter day side, a situation that pinches any consideration of potential habitability in the bud. Not necessarily, though, because between these two extreme zones, there could be a thin strip that offers life-accommodating conditions. Basically, the sharp contrast could actually have a positive effect on the circumstances in a twilight zone. The scientists' simulations have shown that the habitable region could draw its supply of liquid water from the glaciers on the night side. These glaciers would melt near the twilight zone and subsequently feed lakes and rivers. What about the temperature? Well, the specialists calculated an equilibrium temperature of minus 39 degrees Celsius. To explain briefly, the equilibrium temperature is the temperature that sets itself after a sufficiently long time in a system. However, this does not mean that the equilibrium temperature necessarily corresponds to the surface temperature. If Proxima B has an atmosphere, this can be significantly higher due to the greenhouse effect, a situation that our own Earth can also illustrate. Without an atmosphere, the Earth's equilibrium temperature would be minus 8 degrees Celsius. Is there life on Proxima B? The answer to this question, or more precisely, the existence of liquid water, depends on a number of parameters that have not yet been fully explored. Assuming a proper orbit and a favorable atmospheric composition, a 2017 simulation concluded that cool water on Proxima B could indeed flow around happily. Despite this, the planet's habitability is still fiercely debated, mainly due to the violent activities of its host star. A few years ago, researchers at the University of Colorado observed something that dwarfed all previous observations. It has long been known that our sun routinely grabs attention with eruptions of radiation, known as solar flares. However, what the researchers saw flare up on Proxima Centauri was thousands of times stronger than any solar flare observed to date. Within a few moments, the star increased its ultraviolet radiation by a factor of 14,000. In fact, the eruptions there are not only significantly more intense than those in our solar system, but also much more frequent. Against this backdrop, it can be assumed that the extreme radiation will eventually destroy the entire atmosphere of Proxima B, wiping out any chance of life developing. But if the exoplanet had a social media account, the relationship status for life would still read, "It's complicated." There is a scenario in which Proxima B does not lose its atmosphere to space. For this to happen, the planet would need a liquid core that forms a stable magnetic field, thereby protecting it from the dangerous radiation of the parent star. In this way, oxygen and water molecules would be retained on the planet. It is also possible that the planet is still drawing from its original stock. One hypothesis suggests that the exoplanet was actually formed at a much greater distance from its central star and was only gravitationally captured later. It is also possible that there was once 10 times more water on Proxima B than on Earth. Even if the extreme radiation has already robbed 90% of the water, there would still be enough today for a vast ocean covering large parts of the planet's surface. However, as you can imagine, the water temperature would only be moderate in the narrow twilight zone. On the night side, the water would be permanently frozen, while on the day side, it would resemble a boiling pot of mysterious signals and artificial city lights. If there really are highly developed alien civilizations out there, they have probably left behind a technological fingerprint. Since 2015, the members of the Breakthrough Listen project have dedicated themselves to the exciting task of finding these obvious signs in space. And lo and behold, in 2020, researchers captured a possible radio transmission from the Proxima Centauri system, which was immediately suspected of being the signature of a mysterious extraterrestrial society. Then, There were headlines claiming that the James Webb Telescope had detected a brilliantly bright carpet of artificial city lights on Proxima B. Could it be any clearer? Of course not, because this is obviously a false report. In detail, we are simply dealing with the distortion of another interesting discovery. In truth, Webb revealed an exciting methane glow show in the realms of the brown dwarf W1935, and it has nothing to do with extraterrestrial civilizations. And what about the radio signal? Well, in this case, too, the investigation painted a sobering picture for all alien enthusiasts. The signal, named BLC-1, was ultimately of terrestrial origin. It was caused by the distortion of Earth-based radio signals. Thus, the mysterious WOW signal from 1977 remains the most promising candidate when it comes to the question of extraterrestrial messages. Researchers are now pinning their hopes on future studies by the James Webb Telescope. Wouldn't it be possible for Webb to take a closer look at Proxima B and capture the exoplanet on film? Unfortunately, there is one huge problem. The celestial body orbits so close to its star that it can hardly be distinguished from it. However, scientists are currently looking for a few tricks and favorable conditions that will allow them to closely examine the alien world using spectroscopy. And we will tell you a trick that will allow you to stay updated. Simply press the like and subscribe button to keep up with our future videos. Is Proxima B Earth's astronomical twin? Since its disclosure in 2016, the nearest exoplanet to Earth has been associated with concealing an intriguing mystery. It very well may be shockingly like our home planet, and maybe even harbor life. Regardless of its closeness, Proxima B has stowed away its true face from us for quite a while. However, now the James Webb Telescope is targeting our adjoining world to figure out its true foundation. But what have the stargazers found? What is the story behind the baffling signal from the Proxima Centauri system, which is said to have an artificial origin? And is it true that Webb has found a brilliantly lit alien city there? We should start with a little test question. How many planets are there really? 8 or 9, considering that we're still counting Pluto? Well, not exactly, because we mustn't forget one thing. There are also countless planetary worlds outside our solar system. We have now found no fewer than 6,911 planets in 4,941 systems that orbit a host star other than the Sun. However, the bottom line is that the celestial bodies identified so far are just a small tip of the cosmic iceberg. Experts estimate that there are up to 50 billion additional planets out there, and that's just in the Milky Way, mind you. And if we now remember that our home galaxy is just one of billions of other galaxies in the universe, a crucial question arises. Given the overflowing abundance of the universe, is it even possible that Earth is the only celestial body to have produced life? Many scientists answer what is likely humanity's oldest question with an emphatic no. And it's only a matter of time before we encounter our extraterrestrial neighbors for the first time. True to the saying, why wander into the distance when the extraterrestrial is so close? It could be that the next alien civilization is practically sleeping right on our cosmic doorstep. After all, no other known exoplanet is as close to us as Proxima B. The distance separating us from this alien world is just 4.2 light years. And let's be honest, what's 4.2 light years? Well, that's 3,784 trillion kilometers, and with our current means, it would take 6,300 years to bridge this enormous distance. Luckily, humanity is now in the comfortable position of being able to explore the mysteries of space without leaving its own home planet. As mentioned earlier, we have known about the existence of our nearest neighbor to Earth since 2016. We also know that Proxima B does not solely orbit its host star, Proxima Centauri, in the constellation of Centaurus. This is because it is orbited by at least 2 other planets. But how do you even find a celestial body that is more than 37 trillion kilometers away from us? Are the James Webb telescopes of our time really so powerful that they can track down these alien worlds directly and capture them on film? Well, not quite. The truth is that indirect detection methods have proven to be the most reliable for success. This applies, in particular, to the transit method, in which a planet reveals its presence by changing the brightness of its host star as it passes by. In the case of Proxima B, however, it was the so-called radial velocity method that revealed its existence. In simple terms, this detection principle works as follows. A star attracts a planet with its gravity, which in turn orbits it. Conversely, the planet also exerts a small gravitational effect on its star, causing it to wobble slightly. And although the stellar dance sometimes only covers a few centimeters, that is enough to tell astronomers that our star charts need an update. Is Proxima B the Earth 2.0? To be included in the list of potentially habitable worlds, a planet must first meet a basic requirement. It must be located within the habitable zone of its home system. In other words, it must orbit its star at a distance that allows water to exist on it in a permanently liquid form. However, the mere presence of the solution of life is by no means enough. Other factors, such as the atmospheric composition or the radiation of the host star, can still hinder the development of life, despite all the favorable conditions. But what is the situation in the case of Proxima B? Well, with a mass of 1.7 Earth masses, the celestial body is considered an Earth-like exoplanet. However, before we get it wrong, the term Earth-like only refers to rocky planets with a solid surface, without making any claims about their habitability. And while our Earth is known to take 365 days to orbit the Sun, Proxima B only takes a little over 11 days. This is due to the short distance between the exoplanet and its central star. While the average distance between the Sun and Earth is around 150 million kilometers, Proxima B orbits its star at a much shorter distance.